Hello again, welcome back. Next up here, speaking to you, will be Moray B. King. Moray received his Bachelor of Electrical Engineering and Master of Systems Engineering at the University of Pennsylvania in the 1970s, where and when he wrote his first paper titled Tapping the Zero-Point Energy, which led to him being invited to work at the IRE Institute in 1979. It also became the title of his first book of 4, Tapping the Zero-Point Energy, Quest for Zero-Point Energy, The Energy Machine of Thomas H. Moray, and most recently, the Water, the Key to New Energy. He has made numerous presentations, and today he will focus on how water is the easiest way to tap the zero point. Moray King.
Hey, thank you. Thank you, Robert.
1 for the money and 2 for the show. The king is in the house.
Have you guys been to Rex Research website? Oh my gosh. He was the first, starting it in the 80s. He did that. All my material is up on his website to be downloaded, including this latest presentation, PowerPoint slides. So you can get the whole slide deck, download it, and wow, this is a celebration of this book, and this book is actually a culmination of 10 years of research, most of which collaborating with you, and especially the people that are doing the research on the water and all the experiments and all the talking behind the scenes. I've been connecting the dots for years and years and years, trying to piece this together. There were so many mysteries, and it really all culminated. It all came together, and I'm very grateful to all of you, because this is really a result of the collaboration of Tesla techies. So let's give ourselves a hand. Thank you very much. You can go out on the web and Google any of these names, and you'll see a story about an automobile or a generator all running on water. And so there's plenty of projects. Internal combustion is running on water. My favorite happened in 2012. A water car from Pakistan. It actually made the international press. It made the AP. And the reason it's my favorite is because of what the reporter said. When the physics professor said, it violates the laws of thermodynamics, the reporter replied, why all the whining about violating the laws of thermodynamics? Tell me one law in Pakistan that has not been violated. Now that's attitude. So what's going on? Is there fraud? Are we making hydrogen or something else? Well, fraud, it's easy. Every scientist can just declare why it's fraud. Any engineer will tell you it's fraud. It's quite simple, because the internal combustion engine, that motor part of the diagram, is highly inefficient. Maybe you get 20%, you lose 80% of your energy as heat on an internal combustion engine. So if you're going to then drive a generator and then drive electrolysis and electrolyzer, you have losses galore in that system just to make it idle. You would have to, it's a spectacular claim, you have to be about 5x over unity just to comfortably idle such a setup. So clearly, this academic community just will ignore it, just say it's crazy, you shouldn't even try it, it can't be, and they're right from an engineering perspective, because if it is combustion, and that is all it is, hydrogen combustion, you're not going to get very much. In fact, you can just run the calculation. If the hydrogen is not compressed, then you would need about 300 to 500 liters per minute just to get the characteristics of a car, the equivalent of gasoline. It's a straight-up calculation. And the electrolyzers on these claims are not even close to producing gases at that rate. So that's why most of the academic community just dismisses the whole thing. Well, is it hydrogen? Most people think so. Nearly everyone across the years think it's hydrogen. But electrolysis itself can't even yield excess energy. After all, it simply takes more energy to break apart the water molecule than you get back when you burn the hydrogen. It's straight up thermodynamics, straight out of textbooks. Moreover, another way to look at it is that water is in a low energy state, and you have to put energy in to get it up to hydrogen. That's a higher energy state. And if it's atomic hydrogen, it's higher energy state still, you have to put more energy up in. And if it's a plasma state, still more energy as well. So to drive it into these states, you're putting energy into the system. Well, what about resonant dissociation? Everybody hear about that? Who heard of the magical frequency 42.8 kilohertz? You hear that? Yeah, 800 kilohertz. Where'd it come from? Who did it first? Keeley, right. I learned it from you, so it's no surprise here. So Keeley, interesting, it was in the original literature of Keeley. He said 800 hertz. And I got some of the original work from Dale Pond and from the late Jerry Decker, and they shared it, and Dan Davidson shared some of the original Keeley source material where he said that number. And it's interesting. He said, I converted to ether. That wasn't the frequency to make it into hydrogen and oxygen. That frequency was even more bizarre, down at 600, around 600 hertz in the acoustical range. 600 or 610 he said he made it into ether, and he would also talk about making other things into ether, and I thought it was an unusual number, 42800, not 42801, and not 42799. You know, thinking like an engineer, what's the delta bar around that? It's a pure magic number, right? And Keeley, if you read any Keeley material, he is out of our science. He is channeling. Something's coming through him that's out of this world. And so maybe it's happening to me too. Okay, let's resonate the water. Let's shake it apart at the atomic bonds where the hydrogen connects to the oxygen. What is it? What's the atomic bonds that shake it apart? What do you think it is? It's in terahertz. It's up in the infrared. Very, very, very fast resonance there. No, none of the hobbyists are using that, but Nelson just shared with me that he says in European patents, there's a number of patents where they're resonating water systems in the terahertz bands and getting some interesting effects. And this has been done. So he just turned me on to some new information. And perhaps there's some interesting things you could do there, but that's not what the hobbyists are doing, and that's not what the people are doing. So is it something else? Could it be something else? And you'll see that the reason that I think it's something else, and I think you've heard it from me for about the last 10 years, and I'm going to go over that again, what I think it is. And instead of tearing apart the water molecule, what if these popular ultrasonic frequencies are making something in the water? And it's that something in the water that I've been researching for the last 10 years when I first studied the anomalies around Brown's gas, and then the miracle occurred. I encountered the work of our featured inventor. This would be Walt Jenkins. Here's the project that did not use electrolysis. When I read the patent application, it knocked my socks off because what this did, it was my synergistic miracle because it matched my 2015 presentation. In 2015, I finally connected the dots. Right, I got to the point where I found my cluster, my water cluster. And I knew it was a cloud material, fog material. I learned that it was how it could be strong enough. I never could believe that it could be strong enough in order to get it to the ball lightning. And I presented this information originally here in 2015, and then at the International Water Conference. And basically what I said, if you grab a handful of thunderclap material, and you put it into an internal combustion engine, and then you hit it with an abrupt, wide plasma spark, typically from a discharging capacitor, you're mimicking a thunderclap. You will make anomalous force on the piston. You will make anomalous energy, and it's that simple. It's mimicking a thunderclap. And people find it, oh, it's too simple, they can't believe it. Well, we're going to see it happens in every single thundercloud, we'll see. This is happening right under our noses, and it's the easiest way to get, basically, to tap the zero-point energy. Easiest way. And darn if Walter Jenkins didn't do this, and I am just so thrilled that you're here with us, Walter, to celebrate. Because because of this, everything got completed. I was motivated to do the book, right? Another synchronicity occurred where I'm invited to do the book, and everything fit into place. So this whole thing was a miraculous path for me. But basically what he did is right there in the patent application, just use an ultrasonic pond fogger, just a little cheapie out of China is the most convenient. Why that frequency? Well, that's what they sell. It makes the most visible fog. Very clever, using electrostatic grids to charge the fog and guide the fog. This was very clever. We're going to find out that charging the particle, charging the water cluster or fog particle helps make it more stable. This was great. He invented a wide plasma spark plug. He said it mimicked like a Tesla coil, right? The sphere on top. Nice, wide plasma. Drove it at a high frequency, 100 to 200 kilovolts, right? It kept it going for the entire downstroke of the piston. It's keeping that plasma going for the entire downstroke of the piston. He put everything together. This proves that Walt Jenkins, and the filing date's 2011, is indeed the inventor of the thunderclap engine. So let's give him a round of applause. We're going to hear from him later. So to me, the miracle came through. Everything, all the pieces of the puzzle all fit together right away. But how can fog particles be a fuel? Oh. After all, they're nothing more than symmetrical droplets, tiny droplets of water, and when subjected to an abrupt electrical discharge, you would expect them just to blow apart. However, if they're strong enough and small enough, the surrounding plasma can symmetrically surround it, and the electrostriction of the plasma can start to dimple in the cluster, dimple in the droplet, and take a torus form, and causing it to take a form of ball lightning. And basically, it's manifesting a vortex of plasma that closes on itself. It's like a slinky closing on itself. And notice you have two types of spin. You have a poloidal spin, that's around the circumference, that closes onto a toroidal spin. You have a spin of a spin. This is a precessional motion. And you know when you have gyroscopes and you want to precess them, it's really hard. They want to jerk away. And have you heard of inertial anomalies associated with forced precession of gyroscopes, where you're doing something with the fabric of space or something? Bruce de Palma was famous for this. Well, here it naturally happens in a ball lightning plasmoid. The entire plasma wants to take this form. And what I'm going to be showing is that when it does so, it does something to the fabric of space itself. The ether, zero-point energy, we'll see that it creates a coherence, and it's basically going with the flow, going with the way the zero-point energy and the fabric of space wants to flow, wants to preset. It's a natural precession, and as a result, it's going to give us excess energy. And that's the big hypothesis. Ball lightning coheres to zero-point energy. This form, this plasmoid form. Zero-point energy, what's that? Now, I'm preaching to the choir here, but when I give a talk, I've given some other talks to new people that haven't heard of it, and I go, duh, right? What are you talking about? So you have to forgive me to explain it a little bit. Again, they never heard of it. I never heard of it. Okay, I'm a graduate student in engineering. I'm about to enter the PhD program. I had a roommate that was studying general relativity in physics, and this was in '74 during the oil crisis, and the cars were all lined up at the gas station, and he pulled out that big book by Meissner, Thorne, and Wheeler, Gravitation, and he said, "Have you seen this?" And he kind of opened up to the last two chapters of it, and it was Wheeler's work about geometrodynamics, is what he called it. There's the actual book itself, about this energy of the fabric of space coming from quantum electrodynamics and what it does to the fabric of space as it interacts. And I'm going, 0-point energy, I never heard of this. Moreover, not one professor in my engineering department, either electrical engineering or systems engineering, not one professor heard of it. And I found it in the textbooks. So I showed them. It was right in our library at the university. I got geometrodynamics and started to look at the references. I looked at the physics journals. It was loaded with information on 0-point energy. And I would show them, here they are. And I said, I'd like to do my thesis on that. And their attitude was, well, can you just get away, boy, you bother me. Right? There was that type of attitude. I did jump over to the physics department and then started taking courses in quantum mechanics and quantum electrodynamics and making friends with physics professors. And that's so I could learn about it. And so that's how I really got started on learning. And they thought I was crazy finishing up my coursework on my PhD and now jumping over and starting physics. And so they said, what are you doing that for? That's hard. And I said, to learn it. Duh. Oh, so basically what we have is this energetic vacuum, right? Heisenberg said, something about quantum systems, they have this jitter. It was Dirac who came up with the fact that the jitter is associated with the fabric of space itself. There's this underlying jitter in the fabric of space itself. It gives rise to quickly electron-positron pairs that appear and disappear. And this type of description was given to the 0-point energy or the vacuum energy. And this is the key equation. This equation says that the energy density goes up with the frequency. This is the energy density, how much energy you can pack into a point. And it keeps going up towards infinity. And here's what's amazing. You must have this equation in this form. They can't deviate from it. If they deviate from it, the equations of quantum electrodynamics don't work. That's the most successful theory that we have for accuracy of prediction is quantum electrodynamics. And this has to be the underlying formula to make a Lorentz invariant, so you can do the relativistic version of it, et cetera. And this has led to what the physics community calls the vacuum catastrophe. I just learned this. What a colorful name. Here's a wonderful YouTube by Nassim Harriman. It's very humorous. I highly recommend it. Talking about the vacuum catastrophe. Here's the PBS version, which is the standard academics version of this. And they called it, and the catastrophe is, we're predicting virtually infinite energy in every point, and we don't see that. And so how can that be? Right? And it's a catastrophe as a theoretical failure, but yet the theory is success, but it can't be. And now to an engineer, this might not be so hard, because a lot of times when you see a singularity in a model, right, it implies there's not enough in the model. Maybe more dimensions have to be added to the model. And the physics community actually get that, and they start to do that. Here's a single vacuum fluctuation that's described. Where does it come from? It's tiny. That's called the Planck length. It doesn't last very long. It pops in and pops out, pops in and pops out. Where does it come from? So I asked the question. You know what the response is? That's an improper question. Duh, what do you mean improper question? You can to analyze where it comes from. You either say it comes from nowhere, okay, but then you're giving up conservation of energy, or you say it comes from somewhere, and now you're implying there's a somewhere that's a higher dimensional space. Right? They're your two choices. Wheeler did the calculation straight up. All he did was take that equation and apply general relativity to it, and as the energy density increases, space-time pinches off like a wormhole, like a black hole. He invented the term wormhole. And he said, well, that's a flux of energy, tremendous flux of energy. So it's pinching off, and it means that the energy is entering and leaving our space. It enters through these mini white holes, and exits through these mini black holes. He called this activity the quantum foam. So Wheeler called it the already unified field theory. It's a very simple calculation in a sense. He didn't add any assumptions. He says just take that one equation, apply general relativity to it. That's the fabric of space, and that's where those numbers 10 to the minus 33rd comes from. That's the general relativistic cutoff. That's what general relativity predicts. If things can't go up to infinity, they pinch off. So then you can ask the question, it's a flux entering and leaving, so it comes from a higher dimensional space. And that's what Wheeler derived. It's called the orthogonal flux model. That line there called the flatland slot. Oh, there. That represents our three-dimensional space. That's like the plane, right? Pretend you're flatlanders and you have to look out across the plane, right? You have no awareness of up or down. That's what we are. And then activity comes through at right angles. Like that. That's orthogonal. At right angles, the orthogonal flux. So as it comes through incoherently, just kind of coming through randomly, that's the jitter that we see, the quantum foam, the random turbulence. If there's tilt to it as it comes through, a little bit becomes a line in our flatland slot, which is our plane, and then we start to see that as a polarized vacuum. That's a coherence in the energy, as it turns out. And then Wheeler suggested, gee, maybe the elementary particles are created from this flux. So it's like a whirlpool. This flux comes through, and if there's vorticity to it, and then it maintains it in the plane, we detect it as flatlanders as an elementary particle. And so in this model, it's like a stream flowing, has to maintain the whirlpool in the stream. The zero-point energy flux maintains the elementary particles. And then the rate of that flux is associated with the rate of time and the speed of light. And so you can build up a picture of physics that's consistent. But oh my gosh, it's a paradigm shift. For standard physics community, it's like, we got to start over. So Wheeler's model was very unpopular because they just did not know where to begin to do calculations on something so complex. So instead of having a point particle or a little string, all of a sudden we have the dynamics of a full-blown vortex or vortex ring that we're showing. And yet that could be the nature of our reality. So the physics community is, in general, don't want to go there because the calculations, they don't even know where to start. It just becomes too complex. And so that's why they prefer to stay with standard model and string theory, and string theories evolved to brain theory, which, by the way, means membrane, and they're recognizing the existence of the parallel dimensions in the parallel universes. And so finally, I have company, because I was considered such a kook when I started in the 70s and 80s, suggesting, gee, hyperspace exists, these physical dimensions really exist. And now we got into the 90s, and the physics community started to come on board. And I told the engineers, look, the physics community is now coming on board. And you know how they replied? Oh, they're a bunch of kooks. So I got no traction, still got no traction with my fellow engineers. And he said, everybody's off the rails but me, right? So there we go. And there's self-organization occurs, and that quantum foam gives rise to these pairs of electron-positron pairs that come together. And that's a huge particle. They're like 20 orders of magnitude bigger than a single vacuum fluctuation, right? Elementary particles. So that's a hell of a self-organization for something to come into existence and then go out of existence. But it's interesting to note that Bostic observed in the plasma experiments, where there was all this turbulence in the plasma, that it would give rise to vortex rings, a pair of vortex rings with opposite angular momentum, and it mimicked this pair production type of thing in the turbulence. There's order out of chaos, order from the self-organization. I would have loved to have been his student, Robert Lachlan. He won the Nobel Prize, and his thesis was everything evolves from collectives, everything, including the laws of physics. And a wonderful book. I highly recommend it. But it's right on the money, right on the view. But you can't make tiny, simple assumptions about oh, we got a nice point particle, or we got a nice little string, right? We're way more complex than that. The zero-point energy can be viewed as the basis of everything. And these papers are in the Physical Review, which is considered our most prestigious journal of physics in the United States. And in the 70s, Timothy Boyer was the lead theorist respected in the zero-point energy community. And then Harold Puthoff started to become the lead in the 80s with a series of papers. And Boyer derived that all quantum effects could rise from it, rise from all this activity. Puthoff derived how the hydrogen atom is stable due to this activity. It can be an energy source. This was a very important paper politically because a lot of physicists argue, oh, it's impossible, it violates the laws of thermodynamics, blah, 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 blah. No, this paper proves that it's possible without violating thermodynamics. It can be an energy source. Right? There's a lot to learn how to do it, things like that. They can't do it. You guys can do it. You'll have to inform them. And that can be the source of gravity. Puthoff derived that. And then the very exciting paper he teamed up with Hesher and Rueda saying it can control inertia. And everybody got all excited by that because you can control inertia. That means you can make a field around you and make like a flying saucer propulsion type drive. Right, so Russell really likes that. Right, Russell? So, how do we activate it? How do we activate the zero-point energy? Well, we work with Pringagine's principles for self-organization. Highly nonlinear system, like a plasma. We abruptly drive it far from equilibrium. That's the importance of the abrupt discharge. And we maximize the interaction using ions. And we can build up big effects with vortex forms, especially vortices of ions. This is straight out of the standard electrodynamics. The vacuum polarization of a nucleus, there's steep lines converging to the nucleus. And thus, that's the particle you use to trigger activity, coherent activity in the vacuum energy itself. Because if we can jerk the ions, abruptly move them, you can see that flux gets a little bit bent into our space just from abrupt ion motion, and that becomes excess energy in our space, typically in experiments manifesting as voltage spikes. If electrons are interacting with the plasma, you'll start to see energy build up in the electrons. So they do see the energy anomalies. And the ball lightning, essentially with that precessional motion, ortho-rotates, means twist at right angles, rotates it at right angles. So that zero-point energy interacts with that precessional form, that vortex ring, and twists it into our space, trapping some of it into the vortex ring. And that's why ball lightning gives you the excess energy. We're twisting it in. And so we end up having more. Moreover, it affects the motion of that. They observe a very rapid self-acceleration on these plasmoid events. And what we'll see from the researchers in a minute, there's excess force when they self-accelerate like that, and they manifest excess energy. So there's the key. We got to make those ball lightning entities. Well, do we see evidence in nature? Yeah, we see it in thunderclouds, and the reason we can see it is because our technology has evolved to where we have high-speed photography. John, could you play that, please? And every lightning stroke has a ball lightning precursor. It may play if you click the link, I think. Well, it played yesterday when we rehearsed. You should have been here. It was wonderful. Oh, there we go. And it's a single lightning stroke. We're a few milliseconds for the entire event. We'll let it cycle around. We'll play it again. But that precursor activity is on the order of a millisecond. So it was high-speed photography was the key. It allows us to start to observe nature and see these anomalies. Okay. But as great as underneath the thundercloud, boy, above the thundercloud, the activity is even more spectacular. In fact, above some big thunderstorms, and this was caught in one of the biggest, they had to use high-speed photography to see the phenomena of Sprites. This is an event on the order of milliseconds, and it is absolutely huge. That is 50 miles high, right, this event, 50 miles. It's 30 miles wide. It's for a few milliseconds, this event. And they're lucky. What they have to do when they get up in the planes, or they shoot on top, they just run it like 1,000,000 frames per second, hoping to get lucky on top of a thundercloud, right? And then sure enough, sometimes they got lucky. This one, I think, was made in the 90s. It was caught in the 90s. Who knows what they can do now with the better equipment? Here's, I think the play link will work on this one. This will be, this is loop of the actual high-speed event. So we'll see, it starts from the halo above. So this is actually one event that they looped it themselves. So they'll show it, I think, 5 times across the YouTube. Okay. And here's some of the things they observed. The duration's quite short. Some of the biggest are that big. They see the ball lightning. They see plasma balls, right? These guys are big, about 10 meters in size. And boy, they travel, boom, right up to the 10th of the speed of light. They're launched from the halo, and they detected antimatter from there. This antimatter is made on Earth, and it's made in these Sprites, these Sprite activity. And they learned it from the Fermi Gamma Ray Telescope. I recommend this video. It's really fun to watch. It's pretty short. But basically, the way they detected it is from the event, the Sprite event occurs, and then the positrons that are made don't get annihilated completely right away. They actually start to spiral around the magnetic field of the Earth, and they can come hit the satellite, keep on going, get reflected at the South Pole, come back, hit the satellite again. Whenever they hit the satellite, they'll have their burst of gamma rays from the annihilation. And they knew from the timing of the way that traveled, as well as the electrons traveled, that indeed they were truly creating positrons in the Sprite activity. So we're making antimatter on Earth in nature. How about experiments? What do we see in experiments with electrical arcs? Well, as early as 1907, Professor Trowbridge at Harvard just noticed that when he sprays some water into an arc, electrical arc, it's a lot louder than if he didn't spray the water, right? And he just noted that, didn't offer an explanation, just was puzzled by the event. In World War II, Professor Frungel studied it likewise. He was in Germany, and he studied it well enough to know that that sound, it's not from heat or steam. He studied it well enough there, and he then later applied it to make an echo sounding device to measure the bottom of a lake. They've seen in these water arc experiments, they use them to actually fragment rocks. They have some water in the rock, and they hit it with an abrupt arc, and it fragments the arc. They made some studies of it, and energy measurements, and some of the measurements says, gee, we're over unity. We like have 156% on one. And they just, somebody made a mistake, so just ignored. They didn't pay attention to what they measured. But Peter Grenou made a point of studying this event. And so he is highly significant for making a very important contribution to the field of water arc discharge experiments into water. And what he does is in the chamber, whoops. There's the electrodes. For a very abrupt discharge from a capacitor, it has to be abrupt. If it's not fast enough, nothing happens. Just a normal current in water, no event. If he gets it fast enough, it throws the weight, propels the weight up in the air. High-speed photography, he was able to measure, photograph a plasmoid event at the arc. But here's the interesting one. He blew out the bolts on some events. He never really did measure all the force that was being manifested in this experiment. So electrical engineering professor Gary Johnson.
5 minutes to break, Moray. I gotta,
Wow.
I have to cut you off. The next guy up would kill me. He's a tyrant.
Okay, 5 minutes. All right. I went a little too slow, I guess. Gary Johnson improved the experiment because what he did was he made spherical chambers designed to blow apart and fly up guide wires. So he measured all the energy in the experiment. And as a result, it would get flown high enough in the air, he photographed the event. Every single time, he had more energy being manifested in the experiment, excess force, excess energy, than the original energy stored in the capacitor. Here we have an engineering professor, right, with a repeatable over-unity experiment, right, published in the proceedings of the engineering journals. And how does the scientific community respond to this? Crickets. Nothing. He chose not to offer any theory because he didn't have one. He was offering an experiment. And it's completely ignored, right? A definitive over-unity experiment. Harold Aspin, also a researcher in England, very favorable to this idea. He's written papers on how the ion motion, again, is the source of these anomalies. And on the web, they do these discussion about can we take advantage of that to maybe drive an internal combustion engine. Bit harder with bulk water. Peter Grenot's experiments with high-speed photography. Notice cold fog on every one of these events in high-speed photography. And he knew that fog had something to do with it. It was not steam, not force. It was something to do with that fog. And that was our experimental work from there. I'll go, this is my colleague David Faust. I'll go through this and then we'll take a break. David Faust and I came out to iron together. We were working on this research in the 70s back in Philadelphia. His expertise was in Curlian photography, or corona discharge photography. He was a co-author in a definitive paper written in Science magazine describing the phenomena. And we heard rumors about ball lightning being produced in this apparatus every now and then. With low light level cameras, he was able to measure a ball lightning event practically every time. It just wasn't very bright. But he could give a single pulse on the apparatus and record it. And it was very, very reliable. So that was, just at that point, that's when we both got invited out to Eyring, out to Utah. We came together. In some cases, it lasted over a minute. And what he measured was foreshadowing the discovery of this man who studied the microscopic ball lightning. It's his work that'll prove that we really have an energetic anomaly. Are we at a wrap at this point? For first, how much time do I have? How much time do I have?
We can break whenever you're ready.
Well, I could either go through Ken's shoulders and then break, or break now.
Okay, you want to break now? Okay. Take 10.
Or I can rush through Ken, because you guys have seen me talk about Ken's shoulders, right? Most of you have all seen Ken's shoulders work. I'll go fast, because I have a great thing after the break. Okay, I'm going fast here. He makes the ball lightning energies just from a sharp point electrode, capacitive discharge. It runs along a dielectric, and then if it's a conductor, it makes a crater. He noticed the crater was a little too big for the amount of energy on the capacitor, so he started to suspect he has excess energy in the event. Niadi Masyat from Soviet Union also studied these, and he called them ectons. He explained that when just before the EV fires off, a liquid melt starts to protrude off the sharp pointed catheter. Here's a blow up of the point. Little liquid metal comes out, and then the tip of it blows off. And that little blob of liquid metal has perfect symmetry to make the vortex ring around it. So you need that template form to make the ball lightning. And now he's able to launch it every time, and Ken learned to use liquid metal to feed his points like a fountain pen to launch these every time. He called them electron validum. That's where we got the phrase EV. It's Latin for strong charge. They contain about 100 billion electrons. They drag along about 1 million ions. They always exhibit the charge to mass ratio of the electron. So something very fundamental about making something in the vacuum, right? We always seem to get to that charge to mass ratio, and they contain excessive energy. He can make positive ones. These were not comprised of positrons. Right? He was like making a macroscopic positive charge. He knew they weren't positrons because when it hit the conductor, made the crater, it did not give him the gamma radiation you would expect from electron-positron annihilation. So I said that's the most significant ones because you're proving you're making macroscopic charge right out of the vacuum. The vacuum energy, the quantum foam is organizing into something big. And that's the proof of it. That's the most spectacular of his claims. He also makes pairs. He's photographed the pairs, pair production. And you can see they spiral around each other. Here's the black EV. Sometimes he makes them so the dielectric goes dark, and a little electric pulse can make them light up again. And that's what probably Dave Faust was seeing. And they probably happen a lot more often than we suspect, the dark ones. He loved the topic of propulsion. He says it travels up to 1/10 of the speed of light and drags along debris. And the other people, Sarfati and others, have suggested, and Ken really liked this idea, it's like this warp drive. It's a flying saucer propulsion. We're changing the fabric of space as we do this itself. We're warping space. He made basically a propulsion. So if you got control of a field, right, you got yourself the makings of a flying saucer. Here's his biggest event. The biggest anomaly produced came from the vortex. And if he circulates a vortex very rapidly, it's a vortex of water going through a tiny borehole on the order of 1 millimeter. If he shoots an EV right down the center of it, the whole thing becomes coherently ionized and makes a tremendous pulse at the bottom. He called it an EV water gun. It was so powerful, he could not find a way to harness it. It would damage anything he hits. But what he has done is he made a coherence by building up a coherence with a vortex of water, starting with the seed particle, the EV, and made something coherent on a bigger object. And I think this is a perfect break point because I'm going to tell you about a famous inventor here at Tesla Tech that has worked with water vortices in general, and I'll tell you about his water vortex experiments, creating spectacular big effects. So stay tuned for part 2.
Ladies and gentlemen, Moray King. Now he's the opening act for the real guy.